Hi students, now we will move to the new chapter, which is chapter 6, section 1, which is work. If we have, as we look here, an applied force on an object which has mass m, and we have two cases. The first case, this force moves this object for the distance x1, and the second case, the force moves the object a different displacement, which is x2. We have a difference between the distances. For this applied force, the two upper cases, these cases are the same, but the distance is different. If we take the force the same in two cases, the mass is the same, and the direction of motion is to the positive x-axis, but the displacements are not the same. Can we talk in physics that these two cases are the same? Absolutely not, because we have different displacements. The effect, as we see, the effect of the first force on the object is different than the effect of the second force on it, because we have different places. So this effect along some displacement is called the work. Okay, this is the work. In general, in physics, everything in physics, every quantity should be represented by a sample. For the work, the sample for the work is higher case W. The weight is lowercase w. You don't need to be confused about this. The unit of the work is joule, after the British scientist James Prescott Joule. And the formula to compute the work is F, which is the force, multiplied by S, which is the distance or displacement. But the force is a vector and the displacement is also a vector. And the product between them, we need to use the scalar product or the dot product, which is Fs cosine phi between them. We will see many examples about this. In our first example, this is F, its direction to positive x-axis, and the displacement is also in the positive x-axis. The theta between them is 0. Cosine 0 is 1. Now, to see what is 1 joule is equal to, it is equal to the unit of force multiplied by the unit of the displacement, which is Newton by meter. Okay, now also, every quantity in physics, many quantities may be equal to 0. Now we have the force. When or how the force will be equal to 0? This is the relation. We can find all the requirements from this relation. When we can find the work is equal to 0, if the force is equal to 0, we have 3 degrees of freedoms, we can call them. F, which is the force, S, which is the displacement, and phi, which is the angle between the force and the displacement. We can change these 3 things to give us W equal to 0. Maybe the force equal to 0, if we have 3 ways as we see. If the force is equal to 0, then the work is equal to 0. If the displacement is equal to 0, then the work is equal to 0. If cosine theta equal to 0, then the work is equal to 0. When cosine theta is equal to 0, it is at pi over 2 or 90 degrees, or 3 pi over 2, which is 270 degrees. And these are 3 examples of that. If we have a moving object with constant velocity, the acceleration is 0. We have equilibrium. The first Newton's law is obeyed here, yes. the force is equal to 0, then the work is equal to 0. The motion, the body is moving now, but without any acceleration. So the work is equal to 0. Another example, if we apply a force on a wall, the force is not equal to 0. We have a force, applied force, and a normal force. But the displacement is equal to 0, then give us the work is equal to 0. Also, in this case, we have a force upward to lift an object or a box, and the motion in positive x direction. So we have the motion in positive x direction, and the work and the force is perpendicular to that displacement. Phi is equal to pi over 2, which is equal to 90 degrees. Then the work is equal to 0. This is the third case. Here, cosine phi equal to 0. Why? Also, work sometimes be positive, sometimes negative, using the relation. The force, always we have positive force depending on its direction, if it is in positive x direction or in negative x direction. But the force as a magnitude is always positive. We have 10 newtons to the right or to the left. The displacement or the distance is also positive, right, left. But how we control right, left things? We control it by using the phi in our formula. Cosine phi may be positive, may be negative. If the force to the right, okay, and the displacement to the right, then they are both together with positive cosine. If the force to the left and the displacement to the left, then we have both of them are negative. We can't say that the work is negative because the angle between them now is positive. The sign of the work depends on the angle between the force and the displacement. And there is another words to talk if that the object do the work or the work is done by an outside source of force. Okay, let us look now at this example. If we have a force which is 200 newtons and this person pulls the box with angle phi which is equal to 25, and S in positive x direction which is equal to delta x, which is equal to 5 minus 0, which is x0 and x final. If we need to compute the work, it is simply F is equal, work is equal Fs cosine phi. F is 200, S is 5, which is 5 minus 0, and cosine 25, which is 907.3 joules. Okay, this is another example. Now, for the first example, we have the force in positive direction, the displacement in the same direction, and phi give us a positive cosine. So the work is positive. What about this example? If we have an object over a surface, we have applied force 100 Newton, we have a friction force, we have normal force because we have a weight. The displacement S is equal to 0.8 meters. The mass is 2 kilograms. We need the mass to compute the weight. The weight is the mass multiplied by G, which is 19.6 newtons. The friction force is 15 newtons, but in negative x direction, And as we see, the displacement is 0.8 meters in x direction. We have 4 forces. Each force has its work. Look at the work due to the applied force. It is F multiplied by the displacement by cosine phi. Phi is between the applied force and the displacement. Phi between the applied force and the displacement is 0. This is the displacement in this direction and the force also in this direction. So phi is equal to 0. Cosine 0 is 1. We have 100 multiplied by 0.8, which is 80 joules. This is the work for the applied force. What is the work for the friction force? Friction force multiplied by the displacement multiplied by cosine phi between the friction force and the displacement. The friction force is in the negative x direction and the displacement in positive x direction. Then phi between them is 180, which is pi. Cosine for this angle is negative 1. We have 15 multiplied by 0.8 multiplied by minus 1. This will be equal to negative 12 joules. Okay. Now, we have the work due the weight. We have the weight, which is 19.15, 19.6, like here. This is 6. Multiplied by 0.8 multiplied by cosine 270. This is equal to 0. So the work due the weight for this displacement is equal to 0, because the angle is 90 degrees and the not 90 degrees, it is this angle, which is 270. The normal force angle with the force with the displacement is 90 degrees. Then the work also, because of the normal force, is equal to 0. The normal force is equal to the weight in opposite direction, but the angle is 90. Cosine 90 is equal to 0. We have the total work now. The total work, if we need to, if you like to compute it, the total work is equal to 80 minus 12 plus 0 plus 0, which is equal to 68 joules. Now, this is another example. Example number 3. If we have more than one force, just like this one, and these forces are written in the IJK components. So we have F1, F2, F3. And we have just one distance or displacement. This is displacement because it is a vector, which is negative 5i hat plus 7j hat minus 2k hat. We need to compute the total work because of the existence of these three forces. We have two ways to compute the work. The first way, like the previous example, compute the work due to each force alone. So we have work 1 is equal to F1 dot S. We need just to do the scalar product, F1 dot S. It is Fx Sx plus Fy Sy plus Fz Sz. Then the answer will be 32 joules for the work number 1. The work number 2 is the same, dot product or scalar product between F2 and the distance S. It will give us minus 26 joules. The third work is F3 dot S. Just we need to make dot product between these two quantities, then the work will be negative 20 joules. This is the work number 3. Then the total work, we need to add them together. This will give us negative 14 joules. Okay. Now we have another way to compute the work. The work total is equal to the F total multiplied by scalar product as with S. We need just to add F1 plus F2 plus F3. Then we have a new vector which is F total. This is F total. We add F1 plus F2 plus F3, X, Y, Z directions. This is F total. We need to multiply it by the displacement, S. Then the result is the same because it is the same system and the same work, negative 14 joules. Try to solve these examples alone, and we will solve more than these two examples in the future. Good luck.